this robot has very special suspension in a way that it doesn't rely on any shock absorbers or springs like a normal suspension would, as you can see, and the wheels can move freely, both wheels. So right now the track is just loosely hanging on the whole system. However, when you pull down the robot, the tracks is suddenly, like magically, all tightened up, and it's because the gravity that pushes down, it forces these both wheels to expand, and this then makes tension on the track, and that's why it holds nicely. And the same thing goes on the other side, and we don't have to use any shock absorbers or anything to further increase the tension. And the whole point of a suspension is to help the robot overcome obstacles, for example like this one. And right now, as you can see, all 1, 2, 3, 4 wheels are touching the ground or the obstacle, and this increases the traction we have and helps us to overcome our obstacles and also increase the stability on the whole robot. How the robot by itself, so I won't help it, but how the robot itself travels across obstacles. You can see the left track having some problems. Let's just take a look at that. What's going on? It looked like the track is slipping, or basically skipping the tracks, but no, it looks. Now let's try to overcome the obstacle not only by the left or the right side, but the whole robot, so with both tracks. We have a bit of a problem where we just need, looks like we just need to stabilize the robot. Alright, so we definitely have a problem with the left track. Let's take a look at it again. Alright, so what's going on here? So the track isn't as tight as it should have been. But the question is why? Why doesn't it like work? Let's try to just. Maybe it's because the center of mass is. I don't know, where do you think it is? Like here on the wheel, whereas it should be in the center. So we, in the future, will need something to help us control the rotation of the base, so that we can also rotate the center of mass and keep the robot stable. Let's continue. Just maybe use a bit more power right now. Okay, that worked. Let's just. Okay, continue. Alright, and we've done it. So after this test, it looks like exactly that's the problem. It looks like we're gonna have to find a way because the wheels can move freely on both sides. This also means that the whole body of the robot can move freely. However, we need it to be fixed and yet the wheels to be able to move, or even better, to control the rotation exactly like we did on the previous test, where I helped to stabilize it so that when it was like this, so that it doesn't overcome obstacles when the body is, for example, like 90 degrees rotated, and we just want to stabilize it, so put it as much there, basically get it as leveled as possible at all times. And we already have an IMU unit here, so we can actually get the measurement. We just need something to do it, yeah? We just need something, some idea or some mechanism on how to control this movement. So thanks guys for watching, don't forget to subscribe. In the next video I wanna do some outdoor testing, as right now the robot has been tested only in interior, so we have no idea if it's gonna be better or worse than the previous robot in some outdoor conditions, off-road especially, because this robot doesn't have any suspension, but it's also just more rigid and doesn't have this problem as just stays level because it doesn't have any suspension. But I believe that this suspension overall is a big step towards making a better robot overall.